Hello, welcome to the physics lab. Here we're going to talk about Lab 5. Lab 5, which is electric fields and voltage. With me today we have my lab assistant, Michaela. Say hi, Michaela. Okay, she's mute. I'm sorry about that. However, she can help with this. Okay. All right. So this is the setup we're going to have here. Now get a close-up of this. We have the conductive paper. All right. And then we have the multimeter. No Logger Pro this time either. Okay. So what you do here is, let's hook it up here. This is the COM probe on from the multimeter. See, it's got the alligator clip. Do not do this. It hurts like hell. Okay? And don't do this either. It hurts even more. Trust me, I know. Okay, so you want to hook this to here, like that. Can you do that, Michaela, for me? Thank you so much. So the alligator clip from the multimeter to there. That's the COM. And then the alligator clip from our power supply also goes to that same thing. Clip that on there. Okay. Now, the red from the power supply connects over to here. Very good. And now all we have to do is set our voltage right and make our measurements. It's really pretty easy. Yeah. So we turn it on. Now our voltage, before we turn it on, we should do this too. This is what we should have this on. We should have this on 30 volts DC. We should have this set to 225 milliamps. Okay. Now we turned it on, and you're going to adjust this thing here until you get 10 volts right here. Now the problem is that the thing drifts over time. So every once in a while, like every 4 or 5 points, what you're going to want to do is check the voltage there just to make sure it's still 10 volts. Otherwise, you're going to get really screwy data. Probably. Okay. So, right now it says 10.41. Can you hold this, Michaela, so that they can see? As I expertly adjust the voltage adjust and get 10 volts. That's 9. Oops, that's way too far. Oops. There we go. 9. Oh, 10.0. Oh! Close enough. 9.99. All right. Now what we're going to do here is we want to measure the conductivity of the voltage at different points. And if you read the manual and watch the video, you'll know that the first thing you're supposed to do is find the place where the voltage is equal to 8.5. Now we're going to start right here, and even though it says 10 on the conductive paper, what I want you to do is put your finger over that, because then it's a 0. This is your Y plane, this is your X plane, and we're going to start at Y is equal to 0, and we're going to move across until we find the spot where this reads 8.5 volts. And it reads it right there. And then we read that off. And that says it's at 5.5. See, 4, 5, 6. So 5.5. And then we type that in. We'll type that in a minute. And then we're going to go and find the spot also along here where the voltage is equal to 8 volts. So we keep moving along the same line. And we find 8 volts. And it's right there, where V is equal, now the position is equal to 6. Okay. And then we find 7 volts. Okay, and that's at 7.75. All right, so let's type those in over here. And here's our data sheet. I didn't make this up, so if you don't like it, that's too damn bad. All right, so we're going to do the y equals 0. We found it that v is equal to 8.5 at 5.5. V is equal to 8 at 6. Oh, look, it's putting points up there for us. And then v is equal to 7 was that, where was that one? Oh, that's right, Michaela can't talk. Why am I asking her? She's mute. Let's say it was at 7. It doesn't really matter if we're just playing here right now. Anyway, so then we keep going. You see why you want to find that where the voltage is 6, 5, 4, 3, and 1.5. And you fill that all out. Now you move to y equals 1. Okay? So Michaela will demonstrate here, and she's going to find where the voltage along, see this is going to be 10, so 11, which is really 1. And you keep moving that along until you find 8.5 volts, which are going the wrong way. Now you're too far. And I will read it off, and it is at about 4.8. So I type in 4.8 here. And then Michaela, while I'm doing this, is going to find V equals 8 on that line. Bingo. And I got to go over and read it because Michaela is mute. And it's at 5.2. All right, so I type in 5.2. Now come on over here and take a look at this. What happens when I add this point here? When I was adding the first points on the y equals 0, it was just adding them right along this line. But now when I add this 5.2, it's going to add 2 points. All right? And what you see here is, now go find v equals 7. All right, you find it? Don't push on it too hard. That's 2. 6, 2. There you go. Okay. Close enough. And that is at 7.5. So I type in 7.5. And I get more points out here. That doesn't look good. This must have been 8. Yeah. And what you end up with is these lines of equal potential, and you're going to see them, they're going to go like this. Okay? I could take all the data, but then what would be the point of coming to lab? I don't know. All right. So that's all you have to do for this. You just fill out the Excel spreadsheet just like that. This is pretty easy, isn't it? All right. That's the first one. Now for case 2, it's got this line in the middle. Well, what does that mean? That means we have to use bars. No, not that kind of a bar. All right, these metal bars here. Now what you have to do with the metal bars is you have to take a look at them, because some of them are warped, sort of like some of your instructors. Okay? And you put them down here and you see, does this look flat? As it happens, this one here is flat. Okay? But they'll be warped either this way or that way. You want them, if they're going to be warped, you want them to put them down like that, because then it'll make a good connection. All right? So let's pretend that this one is warped like this. You flip it upside down. Okay? It doesn't matter which side is down, whether it's the open side or the down side. Okay? Then, remember we were carefully checking this every couple points for 10 volts. You turn this off. You take this. Oh, watch out! Get out of the way. Get out of the way. All right, take this off. You know what I'm doing right now? I'm screwing up. Okay. All right, and then you take this washer off. You put it down like that. You put the washer back here, and then you put it on like that. Now you want to tighten it up. You don't want to get it too tight. It's sort of like kind of firmly tight, not too tight. You don't want to make long pressure, and then you got to make sure it's straight. It's kind of crooked. And you know what you do then? You do the whole thing all over again after we hook this back up. Okay? So we hook this back on. Set it to 10 volts.
What's the difference?
Well, now we have a conductive plane here. So instead of having 2 point sources, we're going to have a point source and a line. Now, if you put the thing down with the warped end in the middle, like that, you're going to end up with 2 point sources, and it's not going to change at all. Okay? Now, for the third part, you do the same thing, except you use another bar. And you put it where this one is. Now you have it between 2 bars. Okay? And what you're going to see is a different electric field for each of the different configurations. All right? But it's really that simple to teach your data. Okay? I think this lab's pretty easy. What do you guys think?
Yeah.
I didn't listen to it. I wish I could have listened.
All right, well, that's too bad. You'll have to watch the video. All right, so what did you think? Do you think this looked pretty easy? Oh, that's right. You can't talk. You're in the... I keep forgetting that. Oh, yeah, and the secret code. What should we come up with a secret code?
Pumpernickel.
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 Pumpernickel it is. Pumpernickel. So, I'll see you in the physics lab.